Hi, I am Professor D.K. Panda from the Ohio State University. Together with my colleague, Professor Hari Subramani, and a member of my team, Benjamin Mikalowis, we are very excited to present this tutorial at Supercomputing 2025. The tutorial is titled High Performance and Smart Networking Technologies for HPC and AI. As many of you know, we are in a very exciting phase, especially in the exascale computing. We have several systems in the top 500 list which deliver exascale performance. And, and these kind of systems are scaling rapidly with more number of cores, more number of GPUs, more amount of memory, and large number of nodes over the years. And, and these are being driven by all these large multi-mining cores. And also, in addition to HPC, they're also targeting AI specific applications and workloads. And all these systems are also using both scale up and scale out high performance and smart interconnects. Now, in addition to the exascale systems, we also see many interesting deployments at many places, not just a small compute cluster, but very large storage cluster, and also multi-tier data centers like Google, Amazon, Facebook. And many times these systems are also connected together. And that is leading into this kind of integrated high-end computing environments. Now, in this bigger context, if you are an architect and you'd like to see how to build the next generation networks for HPC and AI, you will have a lot of challenging questions. For example, one has to understand to see what are the major bottlenecks in modern HPC systems, why use high performance networks, what are their architectures, what do the communication stacks look like for high performance networks, what are the protocols leading to network architecture convergence, and what are the kind of the communication semantics, what are the features of these networks, and especially the in addition to performance, how are the kind of the management capabilities associated with these high performance networks. And of course, for each of these networking technology, we need to also understand the architecture, the topology, the underlying schemes. And on the top side, we also need to see using these networks how modern software libraries, like let's say the MPI for HPC, or let's say distributed PyTorch for AI, how they're being designed on top of these. And especially depending on your role, let's say you are a sysadmin or you are an end user, you are a manager, you need to understand saying how this kind of a knowledge will help me. Also, we want to see how these modern networks are becoming like a smart. So what does that smart interface look like? What are the features? What are the capabilities? And especially as we are moving into from the HPC to AI workload, what kind of like the high performance network deployments look like? And finally, the question is from all these different knowledge, how can I learn more of these in a more hands-on manner? So, so this tutorial will actually cover a lot of these aspects. Will provide answers to the challenging questions indicated in the previous slides. For example, here we'll go through a set of protocols, like starting from the left, the traditional Ethernet, uh, gradually moving into IP over IB, R sockets, SDP, iWarp, RoCE, and the native IB, and also Omni-Path. So like this, all these modern interconnects have different kinds of layers, and they provide all these layers to the applications. And the tutorial will spend a lot of time actually trying to go over these so that you can understand how these networks actually work. And in addition to the regular networks, we'll also be focusing on smart network interfaces. For example, here like a CPU based NIC and programmable CPU cores with ASICs, and then we'll also be looking at the FPGAs based NIC plus FPGAs. And we'll also be looking at some of the very dedicated network deployment for AI. So here we'll be taking a look at like two of these leading one, like a Cerebras systems and also Habana-Gaudi. So they use lots of core, lots of fast memory, and also high performance fabric interconnection. And more importantly, sometimes even like the Cerebras comes with a single wafer, very big wafer to do very tight integration. So the overall tutorial is a full day tutorial and it is organized as follows. We'll start with a very high level overview of high performance networking for HPC and AI, gradually going into the communication model, semantics. Then we'll be taking a look at some of the basic InfiniBand and high speed Ethernet scale out technologies to get the basics going. We'll also be taking a look at the convergence, the new initiative, the Ultra Ethernet Consortium is coming up. We'll be doing hands-on, and then gradually we'll be moving it to more of these scale out networks like Omni-Path, Amazon EFA, Cray HPE, the Taurus Fusion, the Tofu-D networks. And after that, we'll spend reasonable amount of time on scale up networks like this NVLink, AMD Infinite Band Fabric, and then this the new things which is coming about the UALink. And once we get a good understanding of the scale up and scale out, we'll take a look at the upper level software stack, and especially the two containing ones like the open fabrics, and then the that is the old one, and the newer one is the UCX and Libfabrics. And then we'll take some concrete examples like a MPI interface as an example, and then see how the different layers are being designed on top of that. We'll be focusing on GPU aware communication, and then gradually see how the smart network interfaces are being designed and how they are being deployed. And towards the end, we'll be taking a look at the network trends in top 500 and some sample case studies and performance numbers. And as you can see, we'll also be carrying out as we go along major 4 different hands-on exercises so that you will be able to really work on these modern clusters and get a feel for how these networks actually operate. So this is just trying to show like a one such example, trying to go into more details of like how do you benchmark InfiniBand latency bandwidth, MPI performance, the impact of different kind of parameter, the network parameters like MTU, inline size, transport protocols, how the GPU and DPU awareness are embedded in some of the libraries, and many more. So the tutorial is scheduled on Monday, 17th November. In room 130. It will be a full day tutorial from 8:30 to 5 p.m. And we hope that you will be joining us not only just for the supercomputing conference, but also especially for this tutorial. And until we meet at the tutorial day, if you have any questions on this tutorial, please feel free to ask myself or my colleagues. The emails are indicated below, and we look forward to seeing you at the conference and the tutorial. Thank you.